let's do some test-driven development. I'm going to create a test program where it's going to check for opening or closing parentheses first. I'm going to do it functionally, and then I'll switch it up to where once the mistake is found, it just stops running. The function where it's going to process like the whole string, even when it already has like found the error. But it's going to go into like one way. Once it's found the error, the result is going to be stored as false. But the other one, using the regular for loop, is just going to stop. And then finally, I'm going to be able to like just add a whole bunch of checks. For example, instead of just checking open parentheses, it can also check for square brackets, curly braces, quotation marks, or whatever weird stuff you want to check. All you have to do is you're going to have a list where you just say, I want to check for this. And the program is going to automatically detect what you're checking for, and it's going to do it. All right, so I'm going to use mocha. I'm using JavaScript for this. Okay. Let's see. We're going to initialize the project. I'll name it matching. Matching open close. I'll just use a match test command. I'm using mocha, so I'm going to enter mocha the keywords. I'll just say matching author. I'll put my name in there. All right, I'm now going to install mocha. I'll install it as a dev dependency. All right, and this is going to quickly install. Now create a folder where I'm going to be running all my tests. Put that in a test folder, and I'll create a file in there which is going to be, I'll just call it tests. You can call it whatever you want, but the folder has to be test for Mocha to detect it. And Mocha uses an assertion function, so I'll bring it in. And then I'm just going to describe my first test. Since I'm going, I would say matching open and close parentheses using match. I'll call the function match parents functional. I'll have to create this function later, but for now, I'll just I'll just create the test. And then what should happen? The first thing I'm gonna do is, if you only have open parentheses in the string, it should be false because you don't have a closing parenthesis, right? That makes sense. So you're gonna say assert should equal, I'm gonna use this function, which I've not created yet. And the function is gonna accept this string, the one we're testing for. And we know it's gonna equal false. And since we're testing for the false value, we should also test for the true value. So if we pass in that string in that function, it should return true. Right, and then to run the test, we're just going to run npm test. Definitely, we have to have two failures because the function is not defined, but we ran it just to make sure that this test suite is running. So yeah, so 0 passing, 2 failing, and the reason it's failing is because we haven't created that function. I'm gonna create that function. So, but the way I'm gonna do it is I'm gonna switch up this function here. Instead of just receiving it, I'm gonna be reading off an object. That way I can write a whole bunch of functions, like different functions, and just read them off. And I'll just have to import in one object here. And I'm gonna have to like go out of the test folder and import in that file. And the one I'm making right here. But in order to connect this file with like any other files, I have to export it. All right, and the function I'm exporting is this one right here. It's going to receive a string. And what I'm just going to do here is I'm just going to return true. I'll just return true so that one of the tests passes, because one is expecting false and the other one is expecting true. So if one fails and one passes, then we are in business. So what happened? Matching. So that should be true. It's returning true. I just wrote the function wrong here. Here we go. Okay, so one is passing, this should be true. That one is failing, should be false. But in this case, we're returning true for both of them. So that makes sense. Now let's fix the problem. This is the meat of the program now. I know that I'll keep state of whether the string is true or not. So I'll start with the true state, and I'll just return that state. And then I'm gonna now like go through the string and then store whatever, if it's opening or closing parentheses on a stack. And then just before I return the state, I'll check if the stack is empty, which I'll just use the regular JavaScript length. And then if it's not empty, that means the whole stack hasn't been cleared up and the string doesn't have much in parentheses. So I'll return false for that. Otherwise, as I stated, I'm going to use a function way of doing it. So I'm going to split this string into an array. And once I have the array, I'm just going to use the for each. And then I'll check each element. And then if the element is open parentheses, I'm going to push it on to the stack. And I'll just use element there because it's open parentheses, start element, the same thing. So it doesn't really matter. But I'll specifically check if it's a close parenthesis. I can check for everything else, but it can be a word, a letter, whatever. But I specifically want to check if it's a closing parenthesis. All right, once I know it's a closing parenthesis, the first thing I'm going to do is I'm going to take a peek at the stack. And make sure that the top of the stack is holding an opening parenthesis to match the closing parenthesis. If it is, then we're good. I'll just remove the opening parenthesis. Otherwise, there is no match. So the set becomes false. And this is not going to be reversed to true because we're going one way. And since we're changing the state here, we have to make sure that the state is let. Right, and it should pass for the both tests should now pass. All right, so both of them are passing. Just to make sure that this actually works is we're gonna bring a whole bunch of tests in there, which I'm just gonna copy and paste them in just to make sure. So like the normal one we had there, open parenthesis should be false, pair should be true. This whole mumbo jumbo where the weird stuff in there should be false because you have 2 here, but you have 3 open parentheses or 4 open parentheses. This one should also be true because we're only checking for the parentheses. We don't care about the calibrations here. Here we have a word in there which we don't care about. We also have like the square brackets which are not matching, but we don't care about that. We just care about the parentheses. In the future, I'll do where we actually care about that. And then all these tests should pass. Okay. There we go. The P. All right, that will pass. Great. So what next? As you can see here, we're going through every single string item. What if we just checked for, like, if immediately you see something not passing, you just break out of it? and I'm going to call that functional match parent break. Since we're doing the same test, I'll just bring in this test in there, which I'm going to use this function now, match parent. Make it capitalized there, but they're pretty much similar to that. See, like you have the same regular one we had, the second one there, but here, like here, once you really get there, you just break out of it. So it's going to be similar, but instead of rewriting everything else, I'll not keep state. Let me bring the, first of all, let me run this just to tell you that this is actually passing. So the 6 tests we brought in, they're all failing because we don't have that function yet. And the previous 6 tests are passing. So we're going to make this function. And it's also going to receive a string. But this function, once it goes through everything, it's going to return true. We know that. And it's also going to have a stack. And also, I'll just copy that. We're just going to check if the stack is empty. But the state is not going to be stored in a variable. It's either going to be true once you reach this end, or before that, you're going to have like a for statement and break statement way before you reach the end. And instead of using a function array, I'm just going to use the regular for loop. And I'll use the fact that you can iterate through a string. And then the logic is the same. So you're going to check if the string you are on is open parentheses. If it is, I'll use the same tactic of pushing that string. I can put open parentheses there, but I just like keeping like the variable in there. Else, but we also want to specifically check if this string is actually closing parentheses. If it is, so same logic as before. We're going to do check pick. I'll just copy that. We're going to pick at the top of the stack. Once we pick at the top of the stack, we want to remove it. Otherwise, we're just going to break here. All right. Let's run the test. All right, they're all passing. Now, what if I want to like just have a list of things I want to keep track of, and I can add or remove, like if I want to make it dynamic, how am I going to do that? All right, I'm going to bring in a few tests again, which are going to be similar, but this time I'll include in the curly parentheses, square brackets, all that stuff. And as you can see, I brought in these tests. And this one checks for the parentheses, curly brackets, square brackets. And now all the other tests which were true earlier are going to be failing. For example, this one is false. It was false before. True, like this one is for, okay. Yeah, so like now the brackets matter. Like here, these now matter. Obviously, we don't have that function, which we're calling matches. I need to say that. And to the previous 12 passes, but the new test we've entered in, they're all gonna fail because we don't have that function. Let's write the function. This function is accepting a string. Okay, so we're gonna approach it where we did this one. So I'll just copy this last statement here. Just to make sure the stack is empty. So we'll need a stack. All right, so now what's gonna be new? We're gonna have a list of checks. We're gonna have one which consists of open. Like we're gonna use kind of a kind of hash table where we are gonna have, for example, if you're checking for the close statement, let's start with just the stuff we've done before, but we're gonna use a hash table in this case. So if you start with the key open, the value should be closed. Or if it's closed, the value should be open. As you can see, so we're going to be keeping track of that. But the logic is just the same. So we're going to start looping through the string. All right, now I'm going to use the fact that if I'm if what I'm checking for is in the hash table open, and in this case, if I'm checking for open curly brace, then it's going to have a value. But if the item I'm on the string doesn't exist in this hash table, it's going to return undefined. So I'm going to use that JavaScript stuff to say if I'm checking the hash table for the current item of the string I am on, or the position of the string, it's going to be either return a value or undefined. But if it returns a value, that means I'm in this pause scenario. If it is, then I'm just going to push not the value, I'll push the key onto the stack. And in this case, the key will be open parentheses because we only have one here. Otherwise, I'll also be specific. I only want to check if the item is in the closing hash table. If it is, it should either be undefined or not. But if it's defined, I know I'm in this scenario, like I'm checking for the close parentheses. And then I'm going to add on to like curly braces and square brackets in there. But before that, let's do what we've done yet. So then we make some of the tests pass. Otherwise, we're going to take the same thing we did here. We'll take a look at the top. We'll take a look at the top, but here we don't want to just look for that. We actually want to look for the value of this. Because if we look for the value of the string, it's going to return us, in this case, open parentheses like that. And then we're just going to pop it off. Otherwise, we know the pair doesn't match. All right, let's run this. Some of the tests should pass, some of them should not fail. Okay, so we know, and we're specifically going to go for things like this one should be false, right? And then this one should be false, and this one should be false, because we're not checking for those, so they're going to fail. But at least we know that's working. And then we know this one should be true. And because these ones are going to be true because it's not going through their scenario, so it's going to return true there. But at least we know that this one works. So let's make them all work. How we're going to do them? We're just going to add them to this list. But we're going to be prone to errors if we are adding into open and close all the time. So what we're going to do is we're going to make kind of like it's an array of things we want to check for. And in this case, I'll just say I'm checking for this pair. And then I'm checking for that pair. And then I'm checking for this pair. So that in the future, I'm just going to come for the checks. I can remove them quickly, add them quickly without worrying about any logic. Because I've done that, I'm going to programmatically like populate the open and close parents. And I'll just use a regular for each. Then each item is going to come with like a pair like that. So what I'm going to do is I'm going to destructure the key and the value of that item. And I'll just use like the regular string value. I know the first item is open and the second indexed one is going to be the value. And I'll just use that to return, like to populate open. In this case, open, which is going to receive a key, is going to have the value, and then close. This time it's going to receive the value. It's going to equal the key. All right, this is going to programmatically populate the open and close. And so whatever we're checking for here is all going to be in there. And if we run the tests, they're all beautifully passing. Cool. Well, this was a way of doing test-driven development 3 times in this case, where we just checked for open parentheses. Then we checked it by breaking out of it or optimizing it, and then using that same tactic to where now we can check for anything.